Coming to you straight from Manila, Philippines. This is RiseUp With Esther. Today we're talking about the discovery of a superconductor by scientists from South Korea. A team of physicists affiliated with several institutions in South Korea is claiming to have created the elusive room temperature or ambient pressure superconducting material. Scientists around the world have been trying for more than a century to find a type of material that would conduct electricity without resistance. A discovery of such material would revolutionize the electricity business because it would mean that electricity would no longer be lost to heat dissipation as it moves along power lines. It would also revolutionize the electronics business because engineers would no longer have to worry about heat dissipation causing problems in devices. In their two papers, the research team describes the new material, which they call LK99, and how it was created. It was made, they report, by a solid-state reaction between lanarkite and copper phosphide. The reaction, they claim, transformed the mixture into a dark gray, superconductive material. In their papers, the team claims to have measured samples of LK99 as electricity was supplied, found its sensitivity fell to near zero. They also claim that in testing its magnetism, it exhibited the Meissner effect, another test of superconductivity. In such a test, a sample should levitate when placed on a magnet. The team has provided a video of the material partially levitating. They claim that the levitation was only partial because of its impurities in their material. The papers by the research team have generated much excitement and skepticism in the science community. There have been other instances of researchers claiming to have found room temperature or ambient pressure superconductors over the past several years. If their claims turn out to be true, the team in Korea will have made one of the biggest breakthroughs in physics history, no doubt leading to revolutionary changes in electronics and certainly Nobel medals for all those involved. So how do superconductors work? The modern world runs on electricity, and wires are what carry the electricity to every light, television, heating system, cell phone, and computer on the planet. Unfortunately, on average, about 5% of the power generated at a coal or solar power plant is lost as the electricity is transmitted from the plant to its final destination. This amounts to a $6 billion loss annually in the US alone. For decades, scientists have been developing materials called superconductors that transmit electricity with nearly 100% efficiency. A superconductor is any material that conducts electricity without offering any resistance to the flow of the electric current. This resistance-free attribute of superconductors contrasts dramatically with standard conductors of electricity, like copper or aluminum, which heat up when current passes through them. This is similar to quickly sliding your hand across a smooth, slick surface compared to sliding your hand over a rough rug. The rug generates more friction and therefore more heat too. Electric toasters and older style incandescent light bulbs use resistance to produce heat and light, but resistance can pose problems for electronics. Semiconductors have resistance below that of conductors, but still higher than that of superconductors. Another characteristic of superconductors is that they repel magnetic fields. It is possible to levitate magnets above a superconductor. So how do superconductors work? All superconductors are made of materials that are electrically neutral. That is, their atoms contain negatively charged electrons that surround a nucleus with an equal number of positively charged protons. If you attach one end of a wire to something that is positively charged and the other end to something that is negatively charged, the system will want to reach equilibrium by moving electrons around. This causes the electrons in the wire to try to move through the material. At normal temperatures, electrons move in somewhat erratic paths. They can generally succeed in moving through a wire freely, but every once in a while they collide with the nuclei of the material. These collisions are what obstruct the flow of electrons, cause resistance, and heat up the material. The nuclei of all atoms are constantly vibrating. In a superconducting material, instead of flitting around randomly, the moving electrons get passed along from atom to atom in such a way that they keep in sync with the vibrating nuclei. This coordinated movement produces no collisions and, therefore, no resistance and no heat. The colder a material gets, the more organized the movement of electrons and nuclei becomes. This is why existing superconductors only work at extremely low temperatures. So what are the benefits to electronics? If scientists can develop a room temperature superconducting material, wires and circuitry in electronics would be much more efficient and produce far less heat. The benefits of this would be widespread. If the wires used to transmit electricity were replaced with superconducting materials, these new lines would be able to carry up to 5 times as much electricity more efficiently than current cables. The speed of computers is most limited by how many wires can be packed into a single electronic circuit on a chip. The density of wires is often limited by waste heat. If engineers could use superconducting wires, they could fit many more wires in a circuit, leading to a faster and cheaper electronics. Finally, with room temperature superconductors, magnetic levitation could be used for all sorts of applications, from trains to energy storage devices. So the discovery of a superconductor, a material that experiences no electrical resistance, that can operate without extremely cold temperatures or extremely high pressure, would fundamentally change the world. Such monumental breakthrough would drastically lower the cost of technologies like MRIs, deep space radio antennas, and vitally important fusion reactors, while unleashing a whole new era of computers, wireless communication, and transportation. In other words, it'd be a very big deal. Maybe that's why many material physicists around the world were curious but skeptical when scientists from both Virginia's College of William and Mary and the Quantum Energy Research Center in South Korea announced that they'd finally created a room temperature, ambient pressure superconducting material. Their results were published on a preprint server, but College of William and Mary physicist Kyun Tak Kim told New Scientist that he encourages any lab to replicate his work. And that's all we have. Thank you so much for sticking around. More episodes coming right up.